Hello again, CFA friends. In this relatively short derivatives reading, we shall look at interest rate calls and puts. So let's get started. Firstly, we will learn how to create an interest rate cap. So let's suppose that I've got a company and the company has issued a floating rate note. For simplicity, we'll assume they're paying a LIBOR to their bondholder. So what is the worry of that company? Of course, the worry is that, much like anyone who's on a tracker mortgage will know, the worry is that rates may rise, and so potentially they can end up with a higher payment. Now, the way they can hedge this is by approaching a dealer and entering into an interest rate call transaction as the long counterparty. So we will denote this transaction with dotted lines to denote that this is actually a contingency which they may exercise if they feel the need. So in a call option transaction, the long player can potentially receive LIBOR by paying a fixed rate. Let's suppose that this fixed rate is 5% for the moment. Okay, now let's have a look at some scenarios. If LIBOR is less than or equal to 5%, so this is the actual value of LIBOR in the market, then of course our option here will expire out of the money and the company will simply end up paying whatever LIBOR is. So their coupon payment will be equal to LIBOR. However, what happens if LIBOR is now greater than 5%? Well, of course, if LIBOR is greater than 5%, the option becomes in the money because I can now exercise to receive a percentage that is greater than 5, while still only paying 5%. So as I exercise my option, I receive LIBOR and pay 5%. And you can now notice that the two LIBOR payments will cancel out and now effectively be left with one net payment of 5%. So in this case, the coupon payment will be capped at 5% regardless of the actual value of LIBOR. LIBOR could have gone to 15% for the sake of argument. So in other words, what we learn from this picture is that by going long an interest rate call, we can potentially start creating a cap. Now, one single interest rate call is known as a couplet. So a series of interest rate calls that coincide with our payment dates will then form a cap. And the cap will basically ensure that our borrower never pays more than the cap rate. Now let's have a look at other instruments that can also mimic this behavior. So one idea was that of call options on LIBOR, as we just described it. The other sort of similar instrument that can produce profits under the same circumstances is if you had a long put option on a bond. We'll think about what that's going to do. Now, the call option on LIBOR produced profits when LIBOR's increased. So we want another type of product that will also create profits as LIBOR's increase. Well, what do we know about the relationship between bond prices and yields? Well, we know that as yields rise, as rates rise, bond prices fall. So if I had a put option on a bond at a time when rates were going to rise, that put option will be in the money and it will also create similar profits. Right, so let's have a look at the actual payoff picture of a call option, and this is a very familiar payoff picture that you will have seen in other sections of your syllabus. So the idea here is that on the horizontal axis is your LIBOR or the underlying, and on the vertical is your P&L of the position. So of course an option is the right to act but not the obligation, so it will come at the upfront cost of the premium. In other words, up to the level of the strike we will end up paying the call option premium, but beyond that point we will start having some positive payoff. This point here represents our break-even point, and beyond the break-even point is essentially our profit territory. Notice with the call option, in fact, our theoretical profits are not limited. So we denote the maximum profit as infinity, whereas the maximum loss will be the premium paid. And let's have a look at the actual formula for the payoff of a call option. Now, if I just remind you of your plain vanilla payoff of a call option, that was the greater of 0 and S minus X, where S represented the underlying price and X represented the strike or exercise price. So the idea behind taking the greater of 0 and another number is to ensure that our payoff can never be negative. Remember, an option is the right to act, so we won't exercise if we were to lose money. Our lowest possible payoff will always be 0. Remember, when we talk about payoff, we ignore the premium. Okay, so let's translate that in the context of interest rate call options. So we will take again the greater of 0 and the notional principal. Of course, these call options will be based on a certain amount called the notional principal. The index rate will be our underlying rate, so imagine LIBOR. The cap strike will be our X in the formula, and of course, finally, we may have to de-annualize. And as a general rule, I would say whenever we are operating with LIBOR, we tend to use simple 360-day count convention. So if the market rate, if this LIBOR was below the cap rate, then we'll simply walk away. Our minimum payoff will be 0. If, however, the index rate was higher than the cap strike, then we'll exercise for some profit. And here are some examples. So our 5% cap rate represents our strike. There's quarterly settlement, and that's important as far as the de-annualization of these rates is concerned. Remember, these rates are quoted on an annual basis. We've got 2 million notional principal, and we want to look at a couple of scenarios. Scenario number 1, our LIBOR is 4.7. Scenario number 2, our LIBOR is 5.4. Now remember, we are looking at a cap example. Cap signifies an interest rate call. So in other words, if scenario 1 is looking at a LIBOR that's below 5%, that's not going to be particularly exciting, right? Our call option will expire out of the money. But in case number 2, because LIBOR was actually greater than 5%, we'd be looking to make some money. So let's have a look at the actual numbers. Case number 1, as we said, we take the greater of 0 and 4.7 minus 5, which is a negative number. So we can stop there and then for 0 profit. In case number 2, however, our LIBOR is 5.4. So we take the difference between LIBOR and the fixed rate, the strike, multiply by the notional, and then we apply quarterly de-annualization, which is 90 over 360, as given in our case. So our payoff of this option is $2,000. Now, moving on to the other side of the coin, which is, of course, to look at interest rate puts and the creation of floors as opposed to caps. And perhaps I could start again with a scenario. So let's say I've got a company. Again, and my company is paying a variable rate LIBOR to its bondholders. So far, the picture is exactly the same. But what we're going to do now is we're going to take the perspective of the bondholder. So this time you're not the borrower, you're going to be the investor. The investor in this case is receiving a variable rate. Whilst the big problem for the borrower was that LIBORs could skyrocket, the biggest problem for the bondholder the LIBORs could decline potentially to zero. In this case, if LIBOR was zero, then we wouldn't even be getting a coupon. So what the bondholder's objective is to set some kind of minimum payment that they'll never go under. Right? Issue a minimum payment. So how are we going to do this? So again, this time the bondholder will approach a derivatives dealer, and the bondholder will enter into a long interest rate derivative position. This time the position will be a put option on LIBOR. So in a put option, the bondholder has the right to deliver the underlying, and again I'm using a dotted line to denote that this is a contingency which may or may not be exercised, in exchange for a fixed payment. Now this fixed payment, let's say for the sake of argument right now, was 3%. So basically a bondholder never wants to receive less than 3%. Now of course the desire to guarantee a minimum receipt will come at the price or the cost of the premium of this put option. But now let's look at some scenarios. If LIBOR was greater than or equal to 3%, in other words, happy times for our bondholder who's receiving LIBOR, essentially what that would mean is that the put option would expire out of the money. Notice that the exercise of that option would mean that bondholder would be paying more than 3% whilst receiving only 3% back, so that's not going to be really exciting for them. So in that case, the coupon that they end up receiving is simply the current value of LIBOR, which would be higher than 3%, so there would be no issues anyway. But of course, if LIBOR fell below 3%, that is when we would exercise our put option. So now this has become a solid line indicating the put option has been exercised. And notice that our LIBOR payments will cancel out, and what our bondholder will end up netting is a coupon of a fixed coupon of 3%, and that is even if LIBOR were to hypothetically go down to zero. So what we learn from this graph or this slide is that whilst we could use a call option on LIBOR to set a cap, similarly we can now use a put option on LIBOR to set a floor. Indeed, one single put option is known as a floorlet. A series of these put options that coincide with our payment dates would be known as the entire floor. Now also, in addition to being able to use put options on LIBOR, what else could be used to produce similar profits, i.e. profits for the bondholder when LIBORs decline? Okay, remember that's the worry for a bondholder. So we want some form of cushion, some form of protection for the bondholder as LIBORs decline. Well, let's see. We can get ourselves a long call on a bond. Call option on a bond. Well, let's think about why that's going to be good for the bondholder. The bondholder's main worry is a decline in rates. What happens to bond prices as rates decline? Well, there's, of course, an inverse relationship, so bond prices will increase. So in that scenario, our bondholder would want to hold a call option on those bonds, and those call options will have moved in the money and created profits. Now moving on, of course, to the bread and butter picture of a long put option, and that is, of course, applicable also to the generic put option even on shares. So what we are saying here is, again, on the horizontal is our underlying rate, on the vertical is our P&L of the position, and if our underlying rate is very, very high, i.e. above the strike price, we will simply end up paying the upfront premium. As, however, the underlying rate declines below the strike, we will start having some positive payoff. We will eventually reach the so-called break-even point, and any declines beyond the break-even point will result in pure profit. Now notice a put option, of course, is more limited in its upside compared to a call option. With a call option, the upside is essentially unlimited. With a put option, our upside is limited because LIBOR cannot go below zero. Nevertheless, this will be a fantastic hedging instrument for anyone who's worried about LIBORs going down. Let's have a look at our payoff formula. Again, if I just remind you of the bread and butter formula for a put, it will be the greater between 0 and strike minus underlying. Remember, with a put option, I have the right to deliver the underlying, hence minus S, and receive in exchange the monetary amount equal to the strike. Now, of course, we're going to translate this in the context of interest rate derivatives. So again, we will be looking at the notional principle that this derivative is based on. The floor strike will be the X, the index rate will be the underlying, and of course, we will have to apply our usual deannualization exercise in the case that this is a semi-annual or quarterly scenario. So if the index rate is above the floor rate, of course, that's not exciting. The option expires out of the money, but it's when the index rate falls below the strike rate that our long put option holder will wake up and possibly exercise this thing. So let's actually see the numerical examples behind that. Again, our strike will be 5%. Quarterly settlement, so we're talking about a deannualization factor of 90 over 360 and a notional principal of 2 million. So we're looking at two scenarios. Scenario number one, LIBOR is 5.4, strike is at 5. Clearly, that's not going to be advantageous. This is where our put option will be out of the money, simply because nobody would want to exercise to receive 5% whilst paying 5.4 if they had the choice. And in scenario number two, LIBOR has declined below the strike, so that's where we're going to be looking at making some profit. So let's actually see the numbers themselves. So case number one, as we said, the payoff will be 0 and the option will expire out of the money. In case number two, because LIBOR is below the strike, our payoff is given by the notional principal times the difference between the strike and LIBOR times our deannualization factor for our quarterly situation, which gives me my payoff of $1,500. Right, and essentially we have covered the most of the concepts here in this particular reading. As I told you already, it is a very short reading. But now we also want to look at something very interesting, which is potentially combining the two ideas from the same perspective of, let's say, the company or the bondholder, the borrower or the investor. And this is when we potentially set a collar. Let me just preempt the idea of a collar. So, of course, we've got the coupon payment, the floating rate note coupon payment over time. And, of course, I'm exaggerating, but this can go up and down at will. Now, let's take the point of view of the borrower or the company. Now, of course, we said that it is advantageous to the borrower to set a cap. So this could be our cap, which of course is a series of interest rate calls. I should say long interest rate calls. Now, this same borrower, this same company can at the same time, while setting a cap, may also want to set a floor. And this is where it gets a little bit more interesting, because everyone understands why a company may want to set a cap, right? If I'm a borrower, I want to hedge against potential infinite increases in rates. But why would I want to set a floor? Why would I want to set a minimum payment that I'll ever have to make? Right? Normally I would say if LIBORs go down to zero, that's brilliant because I won't have to make any payments. But by setting that floor, and let's be more concrete, this could be 5% and this could be 3%. By setting this floor, essentially this company ensures they'll always have to pay at least 3% on that obligation. So why are they doing this? And the answer is they're not actually buying options here. What they're doing is they are selling or shorting interest rate puts. And effectively what that means is that the cost of the cap is cheapened. So in other words, what we can now conclude that an interest rate collar from the point of view of the borrower, let's actually specify that, from the point of view of the borrower, an interest rate call can be created as long interest rate calls and short interest rate puts. And as I said, the idea behind selling the interest rate puts is to essentially cheapen the cost of this strategy. Now let's reverse the argument. We can still use this picture, but let's say we now take the point of view of the investor, i.e. the buyer of the bond. Now the buyer of the bond wanted the floor. So as we said, an interest rate collar from the perspective of the investor must start by having a long position in an interest rate put, right? The investor must have long interest rate puts in order to ensure that as LIBOR declines, they still receive a minimum payment. Now suppose they wanted to cheapen this. Suppose that it was expensive to buy all those puts outright. So what they could combine it with is a short position in interest rate calls. In other words, by doing this, they'd be selling the cap. And now, of course, there is a disadvantage with this, because if LIBOR were to go up to 15%, they would be limited in the amount they can receive by the strike of the call options, which is 5%. So this is effectively the cap in this strategy. And of course, a corollary of all this is something called a zero-cost collar. In other words, I can play with the strikes and with the prices of my calls and puts in order to create a product where the cost that I'm paying, say on the cap, is exactly offset by the proceeds from the sale of the floor. Okay guys, so this was a fairly short reading. I hope this was helpful to you guys, and all the best in your studies.